We have an area here which is enclosed by those two functions. Y is equal to x squared plus 3x plus 3 and negative x squared minus 5x plus 27. Our area is defined by a concave parabola, which is defined by this equation here. It's also defined by our convex parabola, which is defined in here. Now, this is important to find out exactly which function is it that encapsulates this top area. You can see that the top area here is defined by a blue function, and accordingly, we will call it the upper function, whereas the green function encompasses the lower part of this shape, and we will call that the lower function. Also, we established the upper and the lower functions, but these functions meet at an intersection, which we may at the moment say on the left-hand side is A. And on the right-hand side, we'll call it B for the moment. Now, I want you to see that if we took the upper function and draw it over here and looked at the area below that function up to the x-axis, then this red shaded area will show you this. And now examine the lower function and look at the area below that function and the x-axis. Can you see that if I lay the green area over the top of the red area, I will get the red area, which is the area that we're looking for. And please remember that these areas were between A and B in all cases. And we can write this mathematically as the area which is between A and B. And we have the upper area first, which is the function y, we'll call it yu. Take away the area from A to B of the lower function, and both should be dx. Okay, well now we do know that the upper function, we have a formula for this, and we also know the formula for the lower function, but do we know where they intersect? Do we know A and B, the lower and the upper boundaries? So to find the intersection points, we will need to find simultaneously the equations of y lower equaling y upper. So we can write that x squared plus 3x plus 3 is equal to the upper function, which is minus x squared minus 5x plus 27. Now I would like to move all these terms on the right-hand side to the left-hand side of the equation. And as a cute way of doing that, what I want is now to add x squared here, to add 5x on this side, and to take away 27 on that side. If I did it on the right-hand side, I must do this also on the left-hand side. So I'm going to add x squared, I'm going to add 5x, and I'm going to take away 27. Now I know that everything on the right-hand side will end up 0 because minus x squared plus x squared 0 and so on. But what is this on this side? Well, we can now add. So we've got 2 lots of x squared. Now we have 8x, and 3 take away 27 means I have minus 24. And on the right-hand side, I've got nothing. And to find the intersection points, I'm going to need to find the value of x. And I will do this by factorizing. But before I do this, I notice that 2, 8, and 24 can be both all divided by 2, and that'll make it easier for me. So I can say that my equation is this here, and that's equal to 0. Now I can factorize it. And if you're good at factorizing, this is what you should get. And the solutions of this will be that x is equal to 2, and you also have x is equal to minus 6. So my lower boundary, which will be the lesser number, minus 6, so that means that a will be negative 6 and b will be 2. So now that we know that at our a's, our area must be therefore the integral from negative 6 to 2 of the upper function dx, take away the integral from negative 6 to 2 of the lower function. And because both of these integrals have the lower and the upper limits exactly the same, we can write them all as one integral. At this point, it's best to remove the brackets. Remember to keep the integral as long as you're doing changes in it. Now we're going to just simplify this. So it'll be minus 2x squared. You are now in a position to integrate. And once you've integrated these terms, it's absolutely necessary for you to put them into brackets, square brackets, because this way you do not have to add that constant of integration, because this is definite integrals and they have boundaries from minus 6 to 2. Now we'll insert the upper limit first, and we do no longer need the square brackets. So we'll just say minus 2, and we're having 2 to the power of 3 over 3, and so on. Here I cancelled the 8 and the 2, and that's why I have 4. And now I'll have plus 24 by 2. And that's only the upper limit, because now we have to take away and do the same thing with the lower limit. At this stage, I can see that some of you might want to put it straight away into the calculator, but please beware of the negative signs. There's too many of them. One of them here is negative 6 to the power of 3. That will be a negative number. I will do this manually. Unbelievably, all three terms are actually 144. Never mind, let's go on. But we can cancel this 144 and this 144. And that's 170.67 square units, because this is an area. Well, I hope that you found this helpful, and if it was helpful, then I suggest that you subscribe to my channel, because there'll be more of these kind of videos on areas, but a different variety of them.